Hello and welcome to another episode of the Oxford MAT Livestream. My name's James and today, triangles! I'm joined today by Yuhan, who's moderating chat, and all of you in live chat. Hi everyone. I can see some anonymous people, some named people, some people who are using the username box to complain about an exam they had to do. So hi Emmanuel and anonymous people and Lucia. I saw and Miles and Jamie in chat earlier as well, and Nikita Mazepin, of course. Hi, how you doing? Hope you're all right. If you're here watching for the first time live, let us know. Good to have you with us. The live chat that you can see on screen is over in slido.com. To get to it, you need to go to slido.com/MATLIVE, or you can click on the link on the MAT Live website. In general, all the resources that I put on the screen, the worksheets, the solutions that we talk about, there's a version of that at the MAT Live website, which is here. Probably you found this live stream from that, unless you're one of the few people who hear from just YouTube algorithm stuff. Hi to Nav and Will and Theo and Adish and some more anonymous people. It's always good to have anonymous people along as well. Sometimes I like to imagine that all the anonymous people are the same person. Someone's pretending to be Imre Leader, who was one of the people who taught me maths at university. So that's a pretty deep cut. Thanks, gang. Hi to Gannon and Faith. Right. Let's do the poll for how we day today. Is anyone here from Unique? I've met loads of people over the last couple of weeks, and in the future I will meet more people over next week on the Unique Summer Schools. They've been really good fun, and I've met some people who seem to like the idea of a MAT live stream, so maybe you'll hear now. Good, people are voting for 5 stars, that never happens. Usually everybody votes for 4 stars. You see it saving something in the tank for just in case the MAT live stream turns out to be the thing that really improves your day up to 5 stars. Loads of you know where your day could improve. 5 stars already, and now 2 hours of triangles. Amazing. Where is it going to go from here? Sorry, I get excited about triangles. Question in chat, people saying hello and hi. I think Nav said that it was their last day of, first day of holidays or end of the school year, so congratulations. Somebody says that they're obsessed with the channel, but Amir is here for the first time live, so hi Amir, there you go, you're going to shout out. There's a question about Unique. So to be clear, Unique is a summer school that we run for some people. We give them information about maths at Oxford, give them some sample lectures. It's not an admissions advantage strictly, and it doesn't come with a reduced offer or anything like that. It's just an information thing. Saw the stream on the homepage on YouTube, says an anonymous person in chat. That's pretty cool. Herb has met a large duck, so good job, Herb. Brilliant. I've never seen, maybe they'll check the archives, but I'm not sure I've seen 5 stars win by so much. David in the chat. Hi David. Right, good. Okay. Good to catch up. And Nav wants to know about mentioning the MAT livestream or the Maths Club by name on the personal statement. If you mention the MAT livestream or Maths Club, you might like to put in half a sentence to explain what it is. If you're applying to Oxford, I'd hope that they know what I'm doing. Hi, anyone from Oxford. This is what this is. It's going to be triangles. Other universities might not have heard of what we're up to, so you might like to explain what it means. Especially if you mention that it comes with worksheets and you've been trying the problems. Worksheets, by the way, in a mo, that triangle is going to turn into some questions from a PDF or a web resource. It's a mix of MAT questions and extra questions that we've written that are somewhere in between A-level and maths. You can get all of those on the website. I think I already said that. I'm repeating myself already. Good. Okay, we got about 50 votes, which is quite good in there. Let's turn that off and have a quick look at chat again. There's chat again. I have not seen animation versus maths. Faith's here from Unique. Hi Faith, there we go. Yeah, an anonymous person was here from Unique. Okay, did I miss any more? No, okay, good. Unique is a summer school, don't worry about it. I'm trying to do a shout out to some people I met, which is, it's good for them and then everyone else is confused, which is fine. Okay, right. They know who they are. Remember when it was 1 hour? Yeah, I just talked twice as fast. It was exactly the same except double speed. So not great. I've got a triangle here. Unironically, I would like us to talk about the area of a triangle. because by the time you get to the stage you're at now, you've seen some other sorts of maths, you've learned a fair few things, you know several ways to find the area of a triangle, which is nice. It's good to have multiple ways to approach something. Some of them are good in different situations. Can I have some suggestions in chat for ways to find the area of a triangle? Yeah, okay. Kenna said hi to the people from Unique, having not known what Unique is. Anonymous. Oh, you're coming by for old time's sake. Hi again. You're studying it. Yeah, okay, cool. Right, we're just going to do triangle stuff. Area of triangles. Choosing statements. Live reaction. Apparently I've got to watch animation versus maths and do a live reaction, and there's thumbs ups. I've seen a thumbnail, I think. Why is everyone in chat saying Heron's formula? What is... Okay. Heron's formula is this slightly crazy method. Okay, we'll put it on the list, but I'm putting it far down the list. It's... You let S be the semi-perimeter. I know. Semi-half of the perimeter, the distance from the outside. And then the area is the square root of S times S minus A times S minus B times S minus C. Oh my goodness, I've gone behind my own face. It's an unusual place to write Heron's formula, but there we go. That is, if you have to, that's a formula for the area of a triangle. But the sort of thing I was looking for is half AB sine C, I really like, so I'm going to write down half AB. In my triangle, that's called gamma up there. BH over 2 is another alternative that I like. I'm going to write down 1/2 of vector A cross vector B from Nikita there. I can't remember what Pick's theorem is. Is Pick's theorem the shoelace one? Where you write down, oh my goodness, I think it's this. Is it in the one that's in one of our questions today? We're going to see a formula later on in the hint to a question about the area of a triangle. So there's one where you write down the differences between the coordinates and do something complicated. Oh, is there a Wikipedia page about today's article for today's thing? There you go. Heron's formula is beautiful in a way. I mean, it's sort of, personally, I think it would be aesthetically more pleasing if it didn't involve the semi-perimeter. I think the S, let S equals, is a little bit wonky. But if you write it out without the S, you have to put in this factor of 4 in there, so you know, swings and roundabouts. Always picks the thing about counting the dots inside the triangles. I've never really got on board with that. I'm vaguely aware of that. Something about counting the points and then the ones on the boundary count as half or something for integer coordinates. Yeah, there it is. Thank you, Jay. There's a fact later on that if its corners are at 0, 0, AB and CD, then the area is half AD minus BC. This object, AD minus BC, it comes up in a few different places in mathematics when you have these 4 things. This combination is, it's the same thing as this cross product that Nikita said earlier, which is a sort of vector thing. And it's the same thing as the determinant of a matrix, and all of these things are related. Now, of course, I'm getting off track, of course, because the math syllabus doesn't have the determinant of matrix or cross product or Heron's formula. These are all really complicated. Oh, is that true? A is R times S, where S is the semi-perimeter and R is the in circle. Yeah, so I think that last one might be the same as shoelace, but now I'm distracted by David Filani. Yeah, so I've made the mistake of saying determinant of a matrix, and I think I'm going to be distracted by that for a second. Right, okay, you're trying to solve the equations ax plus by equals some number, and you're trying to solve cx plus dy equals f. That has a unique solution. And you can find it, right, because you know how to solve equations. If and only if AD minus BC is non-zero, which is a bit like saying the area of this one triangle is non-zero. This thing has a non-trivial solution provided a triangle associated with the problem has no area. It's a weird link between area of a triangle and solving equations. That knowledge of that is sort of not really on the mat. This is the sort of thing that you might study at university, but I like to show it to people as an example of how what you're currently learning about solving equations and areas of triangles feels like very different bits of mathematics. But actually there's all sorts of links, and lots of these things are just joined up, and the same friends keep coming back. Like this AD minus BC thing, it just turns up in lots of different places. The shoelace method in general is a thing that people use for finding the area of a polygon. I did not learn this at A level, and I'm not sure many people do. But if you have a polygon, you can write down a version of this fact where you take all of the coordinates of the sides and you do this criss-crossy kind of thing, like how shoelaces are criss-crossy. If you do that, you can get the area of the polygon. It's a little bit fiddly, and I think that even the people who know this rule aren't taught why it's true. So my advice to you would be, if you want to know the shoelace method for polygons, feel free to go and look it up and learn it, and hey, you'll know something new. The only way I know to prove it uses a bunch of cross products and other things going on. I guess dissection, which I don't really want to do now. So that's kind of a taster of, you know, loads of ways of finding the area of a triangle, and we're actually going to learn a few more. Selecting the right one to use is a key skill, I think. And really the ones available to you are this sort of formula and this sort of formula. Base times height divided by 2. Because for the maths admissions test, the syllabus is really limited. Let's have a look at it now. Chat's going to briefly disappear. There we go, let's put chat back on again. Right, is chat hiding? Oh no, I got away with it. We can have chat at the same time. Chat's going to briefly disappear, there we go. And then come back again. Okay, you do not need to know the shoelace method for triangles. I've mentioned it because it's going to come up in one of these questions later on, but you'll see that when we get to a math question later on, it's given as a hint in the question, or I think not even a hint, just a sort of instruction. Use this formula for the area of the triangle. Don't ask tricky questions about where it comes from. We've got a little bit more time in the MAT live stream, so we get to talk about tricky questions. Yeah, I spent 10 minutes talking about the area. You know, hyperbolic triangles are a little bit different. Flynn's here. Hi everyone. Right, good. It's nice to give you something of a little bit bigger than the very narrow math syllabus sometimes, I think. So today we're going to talk about trigonometric functions and areas of triangles. There's some identities that you're supposed to know about sine and cosine and tan. I'd hope that people are relatively comfortable with the ideas of sine and cos and tan. I've got some revision notes because we always do revision notes for these revision sessions. But I hope that you learned some of this actually before the last couple of years of school, that you've met trigonometry probably before. So I'm hoping this isn't news to anyone, but I know there are some people who are watching the live stream to try and learn maths, so we're going to very quickly go through some revision for how sine and cosine and tan work. I am going to switch off chat on the screen briefly so that there's space for the notes to use the whole width of the screen. Sine and cos and tan work like this. They're just ratios of sides, which is good because if you have the angle, you don't need to know how big the triangle is in order to talk about the ratio of those sides. It's this idea about similar triangles, right? You could have two triangles that have the same angles but different sizes. The thing that's the same between those triangles is the ratio of the side lengths. And the ratios have got names. They depend on theta, so they're functions of theta. The functions are called sine, cosine, and tan, written sin, cos, tan. Oh, Mathologer has done a video on the shoelace formula. That's very good. And look, there's a horrible determinant. Good times. Okay. We've got tan is the ratio of sine and cos. That just follows from the definitions. And there's this brilliant fact that you definitely know that the sum of the squares of the sum of the squares on the sides of shorter sides of a right angled triangle sum to the square of the hypotenuse. This is a really good fact that I think you learn much earlier than A level, and hopefully you learn it from someone who can say it rather than from me. Oh my goodness, Pythagoras, I'm so sorry. Pythagoras is not watching this video, so it's okay. I can see people asking admissions questions about maths in real life and about personal statements, but I'm now in triangle mode, I think. So I'm going to stay in triangle mode for a bit. So I'm not ignoring you, and I can see your thing, but I need to come back to it after I've done some triangle revision. Maybe when we're on to looking at questions. Very few revision notes for this section actually. So down here we've got some of the angles in a triangle is 180 degrees. So you can talk about the angles being related. This way to look at the triangle from two different angles. So if I go back up to my triangle, if I look at it with theta down there near C, then I've got this particular idea about what sine and cosine of theta are. But I could also mark in the angle at the top as 90 minus theta. And then from that point of view, opposite and adjacent means something different. It's a little bit like relabeling all the corners. So from that point of view, you get these other expressions for cos and sine of 90 minus theta, which, long story short, turn out to mean that cos of 90 minus theta is the same thing as sine, and sine of 90 minus theta is the same thing as cos. Brilliant, I hope that would happen. I've been saying 90 a lot because for the MAT, the questions are going to be written in degrees if we use angles. If we give you an angle, it will look like 60 degrees or 90 degrees rather than giving you angles in radians. That's because some of you have learnt degrees in school and some of you have learnt radians in school. But actually, if you've learnt radians, you've almost certainly learnt degrees as well. So they're kind of common language that we can always use. You are welcome to convert the questions into radians if you like. All the people marking the questions know about radians. You're welcome to use either, but I have to write the questions in our shared language, which is degrees. Which is why I've written out those facts about the period of sine and cos and tan in terms of 360 degrees for sine and cos, 180 degrees for tan. The thing to remember there is that as you change theta, you might eventually get all the way round again. So if you come all the way around, then suddenly you're talking about the same triangle. Good. I'm really glad that somebody has immediately registered Pythagoras as their username in Slido. We end up with this kind of melting pot of different references to, at the moment, I can see Formula 1 drivers, ex-maths tutors, people who are definitely old mathematicians, and it's just this nice melting pot of people selling comedy usernames. Okay, there are some symmetries on sine and cosine that you should be able to work out, to be honest, from the definitions of sine and cosine, thinking about triangles with positive or negative theta. I guess negative theta is quite hard to imagine. Normally in the pictures you draw, all the angles are positive, so maybe it's not correct that you can work those out from pictures. But maybe you can make sense of that in terms of what happens with the symmetries as you go past 90 degrees. Maybe not. Okay. Jay says, do you really have to put the degree symbol in when writing in degrees but not the radian symbol when using radians? And this is a kind of typical maths bias where for most mathematicians radians are the default, so if you don't put any symbols it assumes that you mean radians, like how for most working mathematicians on logarithms the default is natural logarithms, so if you don't put a base it assumes that you mean natural logarithms when you write log. These ideas about what's normal don't really track over to school maths that you learn in school, which means that when I'm writing the questions I'm not allowed to just write log and hope that you know I mean log base e, and I'm not allowed to write 45 and hope that you know that I mean 45 degrees rather than 45 radians. So I've got to write a lot of bases on logarithms and I've got to write a lot of degree symbols. If you wrote pi over 3 as the input to a trigonometric function, the markers are probably going to assume you've switched to radians. There's a challenge in there, isn't there, to work out a question where the answer is pi degrees. That would really be awful. Yeah, that would probably be too messy. I should not do that as a math question. Good. That was a little bit of a sidetrack. Matt annoys you because they put the degree symbol and you never write it. Well, sorry. Just trying to be helpful. Okay. I didn't realise the little circles were that, aggravating. I'm going to keep doing them, I'm afraid. I don't think they're actually distracting anymore. Herb has just found out about gradients, which are the ones where there's 400 in a circle. I've got a feeling they're French. I don't know anybody who uses gradients. Okay, we got some areas. We got some formulas for the area of a triangle. I've written out half AB sine gamma, but I've also written out the ones with the sides the other way around. So instead of A and B, you can look at B and C. Instead of B and C, you can look at C and A. I've written CA rather than AC. Obviously, those are the same thing, but for me, it's a prettier kind of symmetry if you switch the AB, BC, CA, like I'm reading the edges in the same direction. I don't know, I just thought it looked neater to be CA. Normally I list variables in alphabetical order. Sorry, I've now gone really deep on a formatting thing. Yeah, Nav is not happy. Nav is not happy about it. Oh, right, okay. Right, then Nikita's telling, in chat, I've been distracted because, yeah, I've put a degree symbol in one of the show that answers which is tricky because I've updated the past question. And to make the past question really clear, I've switched it to degrees and I've put loads of degree symbols everywhere, which has made it look quite messy. Actually, pretty much nobody, Nav, you've got a point, pretty much nobody writes as many degree signs as I do. Cosine rule and the sine rule are possibly underrated. I think they're really great. The cosine rule, you see this relationship between sides and angles and cosine, and the sine rule, just brilliant. Relates together the sines of the angles in this really nice, simple way. There's clear something's going on there. All these things are equal to each other. I feel bad because chat are now going a bit surprised about the French, but I really don't have a citation. I don't have a source for that fact, so I think I might have to retract slightly or quickly check. Is it a French turn of the century thing? Yes, gradients were invented in the French Revolution. Yes, I remembered a fact correctly. Hooray! Right, let's look at some revision questions. I'm skipping through. Chat agrees with me that the cosine rule is underrated, so thanks, chat. Let's have a look at some revision questions together. I have got 13 of these. If you'd like to look at them all, you can download the PDF or check the web version, which is compatible with smartphones. It means you don't have to download weird PDFs from the internet. You know, PDFs are good for printing, not that good for humans. You can get those on the website. We're going to talk about some of these over the next 35 minutes, but probably not all of these over the next 35 minutes. So what I'm going to do is turn on a poll so that you can vote in chat for which ones you want to see. I'm going to keep the screen like that while switching on a poll. There we go. Has that worked? I think that's worked. It's so hard to tell. Pixels. Okay, so David's telling me how I missed a message from David telling me how the triangle things work. And just catching up with chat. Algebro uses the sine rule all the time. Full sine rule is underrated, right? Okay, so there's a suggestion in chat, which I tried to allude to, that all three of those objects are equal to something else, which is not in A-level maths. It's not on the maths syllabus, but it's to do with drawing a circle inside the triangle, which we've got a question about later on. All of these things are neatly linked together. Okay, loads of votes for 12 coming in at the moment, and you'll be pleased to notice that I've put the correct number of options in the poll this time. Let's have a quick look at the poll. Just recording this for posterity. Here's the poll at the moment. People are voting to see a bit of everything. Okay. I'm going to scroll up again so you can see the ones up here. I tried to sort them out a little bit so that the ones at the top shouldn't be too hard. So I was sort of hoping that people will vote for the later ones. People are voting for 12, which is fine, and 7, which surprises me. Oh, right. Yeah. 7 has got an infinite sum in it. If you're worried about 7, we've got our episode about series and infinite sums next week. Perhaps I should have moved this question to next week because it's about an infinite series. Last year I did these two the other way round, so we did infinite series first and then trigonometry, so it made a bit more sense. Maybe that's why 57% of people want to talk about 7. Hey, maybe this is a good way to get foot in the door. People are also arguing about 0, and Anonymous wants an explanation for implicit differentiation, which is luckily not on the MAT syllabus, but it's just the chain rule, right? Which is also not on the MAT syllabus. But if you think of it as the chain rule, where one of the letters in your expression is secretly a function, and you should respect that when you differentiate, then I think you can work out what's going on just with the chain rule. I mean the chain rule. Yeah, obviously you might have to use the product rule as well, depending on how creative your expression is. But if you treat it as one of those letters is actually a function, should be all right. Good. And I've got regrets. Right, okay. So 12 has really won this vote. So we're going to do in some order. The votes cast 7, 8, 9, 10, 11, 12, 13. So I think 7 is important, and then 12 and 13, and then maybe back to 10, 11, and then maybe back to 8 and 9 at some point. Okay, I'll do 7 first. Okay. Right, how do I switch that off? You wouldn't know that I've done 100 of these. This is really always feels like the first one. Kind of lack of experience. I think we're doing these ones, and then if we've got time, do a bit more. And someone in chat has said, "Matt flashcards, very loud." Sorry, I haven't updated the Matt flashcards. Maybe next week. Okay. Good. Right. Question 7 then. And I've got it. If you see me looking down this way, it's because I've got a copy on a bit of paper over here. The one on the screen, for weird reasons, the one on the screen is too small for me to see. I know that sounds daft. It's bigger than my head, right? How could it possibly be too small? But oh well, never mind. Okay, so we've got a series that looks like this. The answer to this is almost annoyingly simple once you know a single trick. The trick works like this. It's to recognise that this is the sum of the terms of an infinite series that works, infinite sequence that works like this. 1 minus sine squared x, sine to the 4x, minus sine squared, minus sine to the 6x, and so on. Each term in that sequence is minus sine squared x times the one before. Go with me here. There's a rule for this sequence, right? Like a pattern each time. It's not just random combinations of trigonometric functions. Each one is more or less just sine squared times the previous one. Oh, and a minus sign each time. Minus times minus is plus, so it sort of cancels out the minus signs in between. Okay, that's a geometric series. And the sum to infinity is just the first term divided by 1 minus the common ratio. Just sort of amazingly simple as a result for what happens when you add all of this up. It's almost just weirdly nice. So if you've seen geometric series, then I hope you've spotted that this was an example of one of those. If you haven't, then it's basically impossible for you to know this. And next week, if you tune in, we're going to learn about geometric series. I think I'm going to prove that this factoid works and write out properly that formula for first term divided by 1 minus the ratio. You are expected to know the sum to infinity, the formula for the sum to infinity of a geometric sequence, because it's not too bad. People usually write A for the first term and R for the common ratio, so that these are AR squared and AR cubes. And then this formula that I'm trying to use down here is just that the sum to infinity of all of the terms is A divided by 1 minus R. We'll do lots more about that next week. as I say, these episodes used to be the other way around, so maybe this made a lot more sense. But I suppose this is a kind of advert or foreshadowing for next week. We're going to do lots of sequences that look like this, and they're not as bad as they look. Good. Okay. Akul in chat has put a proof of why this works. So if you're in Slido chat, Akul has put a one-line proof of how this works, which we'll also see next week. Now I feel like I've got to try and get it on screen as well. 2 seconds. I like it when people in chat do some maths as well. There you go. Pause the video if you want to see proof that this works, or a way to prove that this works. Cool. And just for nav, I've got one of these, which is sort of stylus. Okay. Gannon wants to know why we're learning about geometric series, and I should stress that we're going to learn about them next week. We think that people learn them right at the start of year 13, or equivalent. So we know they're in the second year of maths content, but we think that people learn them just in time for the MAT. You're watching the MAT livestream, you're going to learn them next week, so you're getting a bit ahead. Something to do over the summer holidays, right? Let's learn some sequences and series a little bit ahead of schedule. And then when you get back to school, you can impress everybody by knowing how to sum 1 plus a half plus a quarter plus an eighth, which is another example. Right, again, trailer for next week, I think. Okay. 12. 12 is the triangle inequality. Let's write out the cosine rule. And the question's about cos alpha. So I think I want to write down the version of the cosine rule that's got a cos alpha in it. What am I doing? Writing down something that's not quite the cosine rule due to plus and minus sign errors. Take it again from the top. C squared is equal to a squared plus b squared. No, I have a complete meltdown over here. Sorry, noisy. Right. A squared is equal to b squared plus c squared minus 2bc cos alpha. Look at that. As if knocking over a water bottle magically made me able to do the cosine rule, we've now hit the cosine rule. Brilliant. Let's rearrange this. I'm really sorry about the noise. I hope that was far enough away from the microphone that I haven't hurt anybody. Yeah, I got there third time lucky. Thanks, chat. Third time lucky in the chat on the question. So that means that because cosine alpha is between -1 and 1, this thing over here must be between -1 and 1. And like a lot of math questions that we'll see in the future, I'm not totally sure where this is going when I write it out. But hey, I think this is true. We've done some division to solve for cos alpha from the cosine rule. We've rearranged it. And then because cos alpha is less than or equal to 1, it's between -1 and 1, sorry, we've got this. Not obvious to me where this is going. Maybe I'll write these out as 2 separate facts. So this one over here on the right says this, and this one on the left says this. Okay, and I can see that this 2bc reminds me of what happens when you multiply out something like b minus c squared. So if I bring it on the left and rearrange, I think I get this. And if I bring the 2bc over here, I think I get a squared is less than or equal to b plus c all squared. It's kind of cool. I guess this one over here means that if all the sides are positive, then a is less than or equal to b plus c. This is kind of cool. This fact's down here, and really I should be really careful with the square roots and things. But this fact down here says that each side of the triangle, in this case a, is shorter than or equal to the sum of the other 2 sides. In fact, if it's equal, then cos alpha is exactly -1, which means the angle is 180 degrees. So if it's equal, then cos alpha is -1, So the triangle is 180 degrees, 0 degrees, 0 degrees, which I'm not really very happy about being a triangle. Oh yeah, I didn't tell you why 90 degrees was excluded, but Anonymous in chat is right. The formula for geometric series only works if that ratio is bigger than -1 and less than 1, and it's strict. Those numbers aren't included. Okay. So this triangle inequality, I've got some other ways of saying it in the question as well, but it kind of falls through from the kind of algebra. One of the nice things about the cosine rule is it takes these geometric problems and just gives you some algebra to sink your teeth into. So we had the cosine rule just off the top there, up here, and just immediately start playing with it, rearrange it, write down this. I've also got this other fact, which I think says the difference between two side lengths has to be at most the other one. Is that interesting? I'm not so sure. If the sides are very different, then you can't get your third side to reach between the other corners, something like that. Sometimes I've tried to understand the triangle inequality by imagining, you can tell me whether this is stupid or not, by imagining the side A, right? And then the other two sides of the triangle like this, right? Like B and C, they're sort of like waving around, like this. And if B plus C is too small, then they can't reach each other, so you don't get a triangle. If B plus C is a bit bigger, then you do get a triangle. Sometimes I've found that as a sort of helpful thing of remembering that you don't want B and C to be too small. Also, it lets you do this, so it's sort of vaguely fun. Hi Oscar, hi anonymous people. Okay, so the second one the same as the first one with the letters labelled differently. Maybe. Pass, I think. Yes, it is. Yeah, no, it really is, isn't it? And there's two possible square roots, there's two cases, because I don't really know whether B minus C is positive or negative, depending on which one's bigger. And then I'll move on to the other side and I'll get something else that looks a bit like the triangle inequality. Okay. Yeah, I'm not really sure if this is valid. There's a criticism in chat that maybe the cosine rule requires the triangle inequality, or vice versa. It depends which thing you think is fundamental, whether you start by defining the cosine rule, or if you start and use that to define your angles, or if you start from somewhere else, like your notion of distance. We are getting dangerously close to talking about metric spaces here, and I don't want to talk about metric spaces now, but there is a Maths Club episode about metrics. So if you search for the Oxford Online Maths Club on this YouTube channel, there's a video about metrics somewhere else on this YouTube channel, talking about other things you can do. Okay, good. Yeah, people in chat have spotted that I'm not going to go for, this is something I really want to do, 1 minus 1 plus 1 minus 1 can never be validly argued as 1/2, which I'll disagree. You can argue that that's 1/2. You can argue a lot of things, and in fact the formula that we're going to see next week doesn't work for, doesn't apply for that particular sum, which is a bit like A level saying, "Hi, I can't deal with that sum. I can only deal with these other sums." No comment on other ones. Metric spaces are different ways of defining distance. So you might define the distance between 2 points as like this Pythagoras thing, a squared plus b squared square rooted, or you might define the distance between 2 points to be literally how long does it take me to get from A to B. I live slightly further from the shops than the crow flies, because I'm not a crow. I can't do the as a crow flies distance, I have to go via the road network. So you might come up with this other definition of distance. Metric spaces is the study of all possible definitions of distance. What properties would they have in general, and can we say anything about all of them at once? It's a pretty cool topic. You can have distances that refer to how relatively prime two numbers are, whether they share a lot of factors or not that many factors, to define a sort of distance on integers. Never mind. Right, good, okay. Oh yeah, and people in the chat are interested in taxi cab. If I'm not a crow but I am a taxi, then I have to go along the road network, which might be like in Manhattan, a load of grid, other things like that. Everything in the mat is normal Euclidean geometry, and I know that even just saying normal Euclidean geometry rings alarm bells for people, but everything's normal and nice, flat. Right. The formula for, hang on a minute, let's just put something on screen. The formula really only works if the modulus of r is less than 1. Greatly negative r is not okay. It's not cool. In terms of geometric series and A-level maths. Really feels like I'm setting something up there, but I should not. There's a playlist in chat. Possibly a playlist for this. I should not click it in case it starts playing this video that I'm currently in. Or worse, some kind of music video from the 1980s. Right, okay, what else are we doing? We've done 7 and 12, and I think there were some requests for 10 and 11. Stop me if you're not interested. Well, no, don't stop me if you're not interested. Yeah, the Riemann zetas. The chat is now talking about Riemann zeta functions. This is why, chat, this is one of the reasons that you're not permanently on the screen. You're distracting me, but you're not distracting anybody else until I read out your Riemann zeta facts. Right, okay. I love how chatty chat is sometimes. Good times. Right, okay. We have been asked to look at number 9 and number 10, I think. 9, 10, 11. Whatever, let's go. Cos of 450 minus x. And I think I put this in to try and get you to combine together some of the ideas. So cosine has period 360 degrees, which means that if you write this like this, right, you probably wouldn't actually write this out, but this might be what you're thinking in your head. 450 is 360 plus 90, so that's just cos of 90 degrees minus x, because cos repeats every 360 degrees, so who cares that you added another 360 inside? That's the same, mate. So now we're looking at cos of 90 minus x, and we had something earlier to say that that's the same thing as sine x. So I guess I've combined together two rules at once there to give you something new that probably you haven't been told before, right? That cosine of 450 minus x is the same thing as sine x. Maybe you haven't been told that because it's not interesting, or maybe you haven't been told that because you can work it out yourself from the things that you know. You can never really tell with maths. You get told some stuff and then you can work out some more stuff. Right, good. Hard to do that in other subjects. Not impossible, but hard to do that in other subjects. Right, 10 is a very complicated simplification question. Let's go. Right, let's write out all of the terms. Yeah, so now I'm combining together several facts at once. Oh my goodness. One of those ones where you kind of regret writing it out as you're going. Right, okay. So I can see a couple of 90 minuses. So as just discussed, these ones are not too bad. Let's keep that minus sign in there. Sine of 180 minus x. What do I know about that? Well, so you could do this in 2 steps. You could say, aha, 180 is 90 plus 90. So this is 90 plus something. Aha, so it's 90 minus something as well. Let's write that down. This would be, I'm not sure I'm actually going to use this as an official step of my working out, but you know, here's maybe something you might think along the way. Aha, sine of 90 minus something, so cos of something. So aha, now I'll use a cos is minus cos is, oh my goodness, cos of minus thing is the same thing as cos of thing, and now I'll use the 90 factor. So you might step through several steps to get down to cos of 90 degrees, cos of 90 degrees minus x, using the fact that you can flip the argument on cos. Aha, this is sine of x. But actually this fact is so good that this one you might have been told before, or you might recognize it or remember it. So rather than going through these kind of 4 steps onto here, you might like to remember that sine does this. Sine of 180 minus x is the same thing as sine x. I guess you remember that as being like 2 applications of the 90 degree rule. I'm not really sure. there's a similar fact, which I will let you prove at home, that cos of 180 minus x is minus cos of x. So long story short, this thing simplifies down to sine squared plus cos squared, which is the number 1. So it's testing several different facts here. There's a kind of flipping cosine sine thing in there, there's a minus sine thing going on, there's the 90-degree fact at least once or twice, and then the sine squared plus cos squared fact. People in chat seem a little bit surprised that it simplifies so very much. That's an example of me being nice, that I thought it'd be nice to have something that properly simplified down. Do you need to know these identities for the MAT? Let's have a quick look back at the MAT syllabus to find out what we need to know. Yes, up here. What have we got? Sine of 90 minus x is cos, sine squared plus cos squared, yep, and definition of tan, yeah, periodicity means the way they repeat. Crucially, you need to be able to combine them together. That's true of a lot of knowledge that you have, right? It's not enough to just know the thing and repeat it back. In mathematics, you get to also work with it and to do other things. Basil in chat says cast diagram. And someone else says, if you know the fact about sine, how would you answer the question using sine A minus B? So I had to put this in like brackets underneath because like, some people know sine of A minus B and some people don't know the sine A minus B fact. I'm skirting around how to prove it, but there is this fact. So kind of side note, not maths. I wouldn't expect you to know this for maths. Now, maybe you do anyway, right? Because maybe you've learned this already, which is that this is sine A cos B. Oh my goodness, am I going to get this wrong? It really feels like the sort of thing I'm going to get wrong. There's another one for the plus sign thing. Oh, this is happening. Hang on a moment. Famous moment here. Turns out chat hates the cast diagram. I hate the cast diagram too. These are my people. Oh no. Obviously you can use the cast diagram if you want to use it as a mnemonic, but I can't stand it as a mnemonic. I'm sorry, I can't remember which way round it is. Is it clockwise or anti-clockwise? Or is it left to right? Where do you write the letters? How do you remember that? Good, okay, I've got it right. Good, okay. There's a similar one with plus signs. You can actually work out the one with plus signs if you, wow, this would be daft, but you could derive it from the thing on the board by following through lots of negative b's. Don't do that. It's just quite a good fact. It helps you do this question in this stupid way where you say, aha, the thing in the question is just this with A is 180 minus x and B equals 90 minus x, which is then just, so this thing is just sine of A minus B is 90 degrees, which is 1, because that's the value of sine of 90 degrees. Which just gives you this incredibly straightforward way to do the question, to say, oh yeah, I know this formula. This is, you've expanded sine of A minus B. And I suppose it's like, yeah, that's what I did. That's how I wrote the question. But come on, I wanted to test all of this. I wanted to get you to practice all of this cosine 90 sort of stuff, rather than just get out your not mapped formula that does it. If you haven't seen the formula before, you've got a treat in store. You're going to learn 3 or 4 of these by the time you finish school mathematics, including cosine versions, plus and minus signs. There's another one that's kind of the other way round that, in my experience, people don't remember. It's got sine A plus B on, oh, hang on, it's got sine, I can't remember it, there we go. Sine A, sine B on the left. People seem to struggle to remember those ones. People in chat are talking about cast. How would you prove it? Yeah, okay. So in the question, a challenge above, I said you could only use it if you proved it. I know a couple of ways to prove it. Probably the best is complex numbers. I'm stalling a bit because it's 10 to 6, and I want to do the math questions at 6 o'clock, so I think some people tune in at 6 o'clock to see the math questions, so I don't want to start early, but let's do a definitely not math. Like absolutely not maths. there's this really good formula. The e to the I theta is cos theta plus I sine theta, where I is the square root of -1, and I know how stupid that sounds, but this just turns out to be a really good idea. You can use that to write e to the IA, e to the IB, so those are my two different angles, as cos of A plus I sine B times cos of, oh no, I mean an A over here. Whoops. Oh no. So used to putting A's and B's separately. Sine of, I need to knock over the water bottle again to get back my math skill. Oh my goodness. B. Look, I'm doing unprepared maths. If you multiply out the right hand side, you get something that looks like the equation above. On the left, you can recognise that this is, by powers rules, e to the I A plus B. You can move the powers together. So this tells you facts about cos of A plus B and sine of A plus B. On the right, you can multiply out those complex numbers, and if you multiply out the complex numbers, you get, well, gosh, the things from the formula. Compare the real and imaginary parts, and you get these rules. This explains where the minus sign comes from, by the way. Well, explains is maybe a bit rich. You have to believe Euler's formula to get this. But this minus sign comes from... Oh no! This one doesn't. The cosine rule has a minus sign in it because the square of I is -1. There's a cosine version where I can point at a particular minus sign, and I love to do this with students, say that minus sign there, sadly not the one on the screen, but a different minus sign there, comes from the fact that I squared is -1. We snuck it into A-level mathematics. You learned about this minus sign. Right, we are so far away from maths because I did a not maths and then a definitely not maths. Can't assume that powers work like that. Chat's not happy. Yeah, CIS form thingy. Good, right, okay. I'm not stalling for time, I'm hitting my stride. What are we doing? I'm getting speed up for the other ones. Kind of want to do 11 and 13. Oh, 11's a bit messy, right? There are lots of requests to see 11, which I suppose I'll respect by doing some horrible calculations, right? I remember the number 19 coming in last time I attempted this question. I gave you the angle 120 degrees. I hope you can see, by the way, that's enough information to specify what the other side is, and it's enough information to say what the area is, what signs of the other angles might be. That's enough to specify the triangle, I suppose, to specify the sides and the angles of the triangle. Its position and orientation we may never know, but hey, we can work out the lines, work out the lengths of the sides. So the cosine rule would look like this. It would say that b squared for the opposite side is 3 squared plus 2 squared minus 2 times 2 times 3 times cos 120 degrees. And now there's a bit of a challenge to remember what cos of 120 degrees is. I think it's -1/2, but I'm prepared to be corrected by chat. You all seem to be much better at remembering values than me, especially in degrees. Good, okay, so rearrange that and we should get what b is out the end. And I just vaguely remember the number 19 coming into this, which is a bit awful, really. Let's see, so it'll be 6 and 9 and 4 is, yes, 6 and 9 and 4 is 19. Horrible. Congruent by SAS. Yeah. Which is always good. Okay, what does chat say? B squared is 19. Oh, Gannon says minus 0.5, well done, James. Oh. Not enough well done, James, on the live stream. Not enough things that need to be well done. Not enough things done well. Okay. Oh, cos 120 is sine minus 30. I like that. It's minus sine of 30. In my head, I was doing cos of 120 is minus cos of 60, because I can kind of remember the ones from 0 to 90, and then I need to start using the tricks. The symmetry tricks are good for that, by the way. That they tell you that if you can remember this bit of the sine curve, if you can remember some values on here, that's kind of it. Because after that, it comes back down again, kind of in the same way, and then it goes negative in kind of the same way, but upside down, and then it comes back up again in another one of those. That shape is not quite a quarter circle. That would make it really easy to remember values, I suppose, but sadly, sine is not quite a quarter circle. If you can remember some values in there, you can work out all the others. And then if you translate or shift or flip or something, you can work out values of cosine as well. Though I do find it handy to remember the cosine values and some sine values rather than both. Ah, good. Chat is backing me up. Thanks, chat. Right, there we go. You know what that counts as? That counts as engagement in Slido, which is good for the statistics. Good. And right, okay. How much of question 11 do I want to do? Area of the triangle? We were talking about it before, right? So that'll be half AB sine 120. Where here I'm choosing to work out, I'm choosing to use this formula because I know one of the angles. If I knew the height of the triangle, I'd probably use the half base height one, but not sure I can work that out right now. That's not too bad at all, right? Let's just, there's a root 3 in there, there's some more 3s, I'm getting factors of 2 around. Yeah, I think that's all going to follow through quite nicely. It's giving square roots, everything's going on. Good, okay. The last question, I can't remember if people wanted this or not. We've got a few minutes here. I can pop back up again. I might put the poll on again in a second to pop back up to the first 6 questions, which I don't think we've talked about. I think we skipped 8 as well. 8's fine. This is a new one for this year as a warm-up. I think it's really hard. It's the cosine rule again. I didn't say cosine rule in question 13. I would use the cosine rule for this. You've got all the side lengths, so you should be able to work out the angles by rearranging. And it turns out that one of the angles is really nice. Has anybody in chat had a go at this question? How did that work? Can I make some actually interesting questions instead of these boring apply a set of A-level method style questions? These are supposed to be more boring than math questions. So to answer the question in chat, yes, I can make more interesting questions. And I have to every year in order to write the math submissions test. But the way the live stream works is we spend an hour doing revision and warm up and practice, and then we hit some math questions. Last question? Yeah. Oh, those tricks that I mentioned out loud, sorry. Tricks is my word for all of the sine of 90 minus x equals cosine and the period of sine and cosine. And I sort of count in there as well the sine of 180 minus x is the same thing as sine of x. I call them tricks because it sort of saves you some work. I know that sometimes people say tricks to mean something that catches you out or something bad. Anyway, I do not write all of the math questions. Right. You can use Heron's formula if you want the area. And then once you've got the area, I suppose you could use the sine rule to infer some of the angles. Like, no one's stopping you from writing down... Yeah, okay. No one's stopping you from going down the Heron sine rule route. I think one of the angles turns out to be 60 degrees. It's either 60 or 120, depending on whether cosine turns out to be 1/2 or minus 1/2. I think it turns out to be 1/2. For one of the angles has cosine 1/2. It's got a 60 degree angle in there somewhere. Oops. These triangles have got a name. They're called Eisenstein triangles. You can learn more about them on, for example, Wikipedia. They're really weird in a way. They're a bit like right angle triangles. They've got something that's a bit like Pythagoras' theorem. They've got one angle that's kind of nice, and then they've got two angles that are not nice, and whole number sides. Right, 13 as A, yeah, so you've got to pick your sides. Only one angle is nice. The other two are horrible. So this is why it's a question 13 on the warm-up, because although you are applying an A-level method, cosine rule, there's no hint in the question to use the cosine rule, and it's easy to get disheartened because you can try the cosine rule on this triangle and find one of the horrible angles, and then think, oh no, I don't know inverse cos of 11 over 13. I don't know an angle that has cosine 11 over 13. It's like about 89 degrees. What is this question doing? What is going on? And then you try another one and you find another mad expression for cosine, and you think, oh my god, maybe I'm doing my cosine calculations wrong. And maybe you are, or maybe you're not, because two of the angles are really weird. The sort of skill that I want you to get by doing these questions is not really hard mathematical content so much as a bit of perseverance and a bit of following through, so that if you calculated the cosine rule twice, you're not too fazed by the idea of running the cosine rule a third time. I know that's 3 times as much work because you're doing the cosine rule 3 times, but hopefully the kind of thrill of the chase, or trying to find the angle that's nice, is just enough motivation to write down 3 cosine rules. Yeah, if you do 3, you'll definitely get it, because you'll get it. It's a triangle, it's only got 3 corners. Yeah, sorry. In my head that was a really motivational statement about your search, that it's a triangle, it's only got 3 corners, and then I realised it just sounds so stupid. Speaking of, it is 6 PM. It is 6 PM. If you've been looking at a screen for the last hour straight, remember to blink. If you have been talking for the last hour, remember to drink water. Quick look at chat before we move on to some math questions, which I'm hoping are sufficiently difficult for the person who wanted harder questions. Is this question based on luck? Oh, let's put chat up. Chat's going a little bit. Welcome to MAT Livestream. Triangle only has 3 corners. Is it based on luck? You sort of make your own luck in that we're all guessing the first time we write down the cosine rule. Some of us are going to write down a second cosine rule when it doesn't work. And some of us are going to write down a third cosine rule when that one doesn't work either, because there are 3 angles, 3 ways to do it. So it's sort of luck if you get to do this question quickly, but it's not luck to persevere and get to the answer in the end. Good. Yeah, hydration. Yeah, I'm always glad someone out there, we're going to meet them at some point, can go an hour without blinking, and that person should stop. They should not do that. And I don't mind being the one who tells them. Your skill at not blinking is amazing. Your 1 hour staring contest that you've done with the live stream. Gosh, let's not. Right, okay. You've got to be really careful what you say on the live stream. There was something else good in here. What was the good thing? Sorry if I'm scrolling past yours in search of... Oh, how do you make questions? Setting yourself hard questions? Try to combine things together. The easiest way that I know to come up with hard questions is to try and find links between things, to try and say, what if my quadratic equation was also triangles? Because what if I had a triangle where all 3 sides were quadratic equations for x? So as I change x, all 3 sides of the triangle change? Ugh, it sounds impossible. It sounds really hard to work with. Can I still write down equations for the angles? What sort of formula do you get for cosine of each angle? What sort of rules do you get out of the sine rule for relationships between x? Can you turn those into quadratic equations, and does the discriminant mean anything? I don't know. That's what it's like to write some of these questions sometimes. Just you start from what if quadratics and triangle at the same time, and then you end up with something nice at the end. And sometimes you don't. That's the job. Put it on a postcard. I can't find the math question, so I'm just going to put it on the screen and let you look at it while I find it on one of these pieces of paper. We're going to cut over here for you to look at a picture of this diagram. This is a math question from 2007, and it is question 4. Yes, there it is. It's on that page there. You can find it because it's got a triangle on it. I actually think that'd be a good question. Let me just try it. There we go. There's the question. And I'll just scroll so that you can see the question. Show the coordinates of Q are that. So we're trying to find out where Q is. If we got any general advice in chat, I'd quite like to know how you would approach a geometry question like this. What do you do on geometry questions? What do you do when you've got a diagram and you want to find the coordinates of a point? What do you think about? What do you write? How do you do these? I mean, I've got opinions, but I've been talking for an hour straight, so it feels like I should let other people have the mic by getting you to type in chat. Interview questions are maybe harder than math questions, but the advantage is that the interviewers are there to help. So if I'm interviewing, I can make the interview harder or easier, and I can give hints along the way, so that if we're doing a really hard question together, then I can make sure we get to the end by helping you along the way. I can also spot any mistakes and help you stay on the right path by maybe correcting mistakes or giving you advice along the way. I want to see how you respond to things, how you adapt, whether you can change your plan or adapt to new information. What is the question? Oh yeah, sorry, the question just went off the bottom of the screen, didn't it? There we go. Find the coordinates of Q. Let's actually show you that question. Okay. Right, okay. So people in chat are saying the following things. Draw lines, label everything. Draw lines until a correlation forms. I like that. I'm not quite sure. A correlation sounds like something that might happen in your mind. Draw lines everywhere, but with circles try and draw right angles, centre and coordinates. Yeah, the centre of the circle is a really good suggestion. Ends up with the same thing except theta was theta over 2. I guess that's an angle chase kind of thing. Radii, right angles, tangents, stuff like that. Cool. Sounds good. I like that. And just in case people can't read the reply, yes, but if a student moderator is giving their time to moderate chats, thanks Yuhan. Yuhan is getting paid for their time. Good. I felt like that was important enough that I wanted to answer it too. How can we draw lines if the diagram is going to be on a screen? Yeah, so this year math questions are on a screen, and I guess we might need to draw out our own version of the diagram. Let's have a go at that now. Oh, chat's come back. Okay. Drawing your own version of the diagram is also good because I sort of recommend it anyway, because there's this thing you can do while you're drawing it, which is try to work out how it's put together. So if you're drawing this from scratch, you've got like a triangle, right? Or do you start with the circle first? Maybe I'll start with the circle first, and then I'll put that line in. You see, there's already two ways of thinking about it. You could start with the triangle and put a circle in it, in which case maybe you're thinking about the angles first. Your picture for a moment will look like this if you draw the triangle first. And that's helpful because now maybe you're thinking about stuff you know about right-angled triangles. So if you draw that bit of the picture first, maybe you'll spot that if I label these points P, Q, R, you kind of know some facts about relationships between sine theta, cos theta, and these distances in the question. I'm going to call the origin O. That's a reasonably normal thing to call that O. Matt has an actual answer booklet. It's not just lined paper. Yeah, official booklet. There's no adjustment to the length of the test. Okay. Unless you get adjustment to the length of the test for other reasons. Okay, so if you're drawing the diagram, maybe you draw the triangle first and then put a circle in. It turns out to be quite difficult to do in terms of drawing skills. But the point I'm trying to make is maybe when you're drawing it, you were thinking about the triangle. The alternative is that you drew the circle in early. So you drew in the axes. Axes are a good place to start. They're at right angles, of course. And then the circle. And if you do in that order, you're probably thinking about where's the circle. I know it's got radius 1. So maybe I might draw in these bits here. And then I've got a really nice picture where I found a square. I found a little square with some right angles. Who knows, maybe that'll be helpful later. definitely if I've started to talk about areas, I've skimmed the question, there's areas in here, only the size of a square, so that seems good. Maybe you're already thinking about these right angles down here, which sets you up nicely to find some more right angles. Then if you're thinking about this line as a sort of tangent, then you might draw in this line next. So you might, at this stage, have quite a lot of lines going on. The point I'm trying to make is that the order you draw your picture, it doesn't really matter because you end up with the same picture, but as you're drawing your diagram, you might like to look at your half-drawn diagram and think about how you're getting things in the right place. You've got a load of spatial reasoning skills and spatial awareness, I suppose, that helps you to put things in the right places when you're drawing the diagram. But you might like to think about why you're drawing it there rather than somewhere else. So here I've drawn the circle there because it's tangent to both axes. Because it's tangent to both axes, that reminds me, tangents, right angles. And then I've drawn the line in so that it's touching. And there's some variability here. I don't know what angle to draw the line in. I don't know theta. But it's healthy to think that because now I know that theta is, I've remembered that theta is not a sort of fixed number. It could be changing. Sometimes you get marks for your diagrams. If we ask you to draw a diagram, then we might give you marks for a diagram. If your diagram contains some mathematical ideas, then you can pick up marks just for having the picture. Right, okay. Suggestions for how to actually find the coordinates of Q. You might want to do something like drawing in some extra lines. I think you've got choices. What do I want to do? I think the way I like to think about it is to think about Q as being kind of above the x-axis. I guess I'm thinking about, so this little angle I've called phi, which is a Greek letter that people sometimes use for angles if they've already used theta. Phi, which is spelled phi in English, but is spelled phi in Greek because it's a Greek letter. I like to think about positions like Q over here on a circle. I guess I'm thinking about a cast diagram, but it's a point moving around a circle, right? I don't know where it is on the circle, I want to know where it is, so I might think about the angle above. I guess this 1 has made me think of the unit circle, and I'm pretty good at writing down where Q is on that, right? So this point here is 1, 1. So then that says that Q is at 1 plus cos phi, 1 plus sine phi. I prefer to do it that way around, to draw in an angle that lines up with what I was expecting, and then solve. I know that some people like to chase theta around the diagram and to do things like this, to draw in like 90 minus theta. Where are we going? What are we doing? This is a right angle. This is a right angle. This is like 180 minus theta. Oh my goodness. So you can kind of chase this together, right? This is like 90 plus theta or something. So you can do this angle chasing where you mark in loads of things. I find that quite messy and confusing. Maybe you do too, or maybe at least you find my presentation of that messy and confusing. It both work, either first labelling the angle that you're looking for or taking the stuff you know and following it around the diagram. I prefer to have a target in mind. So for me, it's thinking about phi in here. And it's unlikely that I label this one yet or this one yet. Maybe you did, maybe that's what you did, and that's how you know what this angle here is. Maybe you're very, very good at cos and sine, and as soon as you marked in that angle, you knew to drop things down and up again. But yes, maybe you've spotted the thing that I was hoping you'd spot, which is this angle up here in this tiny triangle that I wish I'd drawn a bit bigger. This angle up here is theta, which you maybe recognise from someone in chat says things about inclined planes in mechanics and the angle of inclination being that angle between vertical and the normal, but I know that lots of people are not too happy with mechanics, so let's not explain it in terms of A-level mechanics. What you might prefer to think of is to just bring this line out a little bit And then you'll see we've got these parallel lines. A straight line crossing parallel lines means you can mark in a theta over here. And then there's a right angle here, so now this gives me a different way to see that this angle over here, based on this triangle, which I'm going to draw on, based on this pink triangle, once you've got that theta, you can get how big phi is in terms of theta. Or you might like to chase the angle up here, so this thing here is 90 minus theta. So this thing at the top is theta, using another right angle. And there's different ways to do this angle chase. I want to show you a few so that you get the impression that there's different routes through the maze. And geometry problems can feel like a bit of a maze, that you've got theta over here, phi over there, and you want to try and link them together by just going around and you're following these rules around. But there's often multiple ways to get through. Yeah, so the answer in the question gives you a hint by thinking in terms of 1 plus something and 1 plus something else. Okay. Anonymous is watching with their son as well. Hello, both of you. Label a target. Have I switched from theta to phi halfway through? Yeah, I've got both in. So recap quickly of what I was doing down here. Oh gosh, I've made that far too large. Theta is given in the question, is this angle over here, or so theta is marked in the question. Phi is the thing that I want. For personal reasons, I think someone faster at trigonometry than me could maybe take the angle theta and do some incredible kind of like cosine. Oh my goodness, I can see it the other way up. I could see that like, this is also theta, so I can see that Q is around. But I like to go for, here's the angle I want, give it a new name to remember that it could be different, and then try and find some relationship somewhere. Yeah, okay. Label a target and then find out what it is in terms of theta. My diagram's got quite messy. I'm a bit limited on space up here. If your diagram gets a bit messy, you might draw a new diagram. Like at the moment, I'm regretting this picture of a square down here. It's nice, it's a square. The square's not going anywhere, and it doesn't feel very relevant right now. I suppose the square gave me the fact that this point is at 1, 1. Labeling the picture has made it much more messy. After that, maybe I know the centre is at 1, 1. Maybe I draw a new squiggle picture without the square marked in, with just the bit I'm working on, which looks a bit like this. Theta, theta, 90 degrees. Aha! This angle in here, my phi angle. So theta, theta, phi, right angle. Aha! Quickly having a side sketch of just the relevant bits can help you reduce clutter and see in your mind's eye a little bit better the way through. Anyway, phi turns out to be, for me, 90 degrees minus theta, and then I'll use the 90 minus trick to flip those into the objects in the question, which are 1 plus sine and 1 plus cos. Okay. And it's a show that question, so what do we need to do? We need to show that, I think. I would definitely write something for this. Because the answer's printed on the question, I would not just do a diagram, I would probably also write out, I know the centre of the circle is at 1, 1. Because the circle's tangent to both axes, I'd probably leave it a bit vague just for speed, right? So I'm writing something short. I know the centre's at 1, 1. The angle of Q above the horizontal is 90 minus theta because, and then maybe at that point I would do my mini diagram or something. That's if I was trying to present it really neatly to make sure I get all of the show that marks for a very convincing explanation. To be honest, if you're on this question, I think if I was marking it, if I was leaving the marking on this, I could see some version of one of these pictures and the right answer, then I think you're right. You can just do that. You can do some writing, I think. I mean, technically, formally for mathematics, you're supposed to prove things rigorously by making it extremely clear what you're doing. in an exam like this one, if you're asked to prove something, you get a little bit of the benefit of the doubt. What I'm really testing is not whether you can write out a formal proof. I can teach you that. I'm testing whether you have the idea. So did you actually yourself work out where the centre of the circle is, being 1, 1? Maybe you just guessed it, or maybe you just copied out 1 plus 1 plus because that's what it says in the question, or maybe you actually had the idea that the centre of the circle is at 1, 1. If you have the idea, I want to give you credit, and I can do that by finding anything that looks vaguely convincing in your work. Of course, you're going to make things as convincing as you can, but you actually get a fair amount of wiggle room. Like you're let off with writing things that are not perfectly rigorous, because we know everyone's humans, not robots. Even if your proof is clunky and doesn't flow, you can still get full marks. Yeah. To be honest, if it was a choice between, no, this is a stupid choice. Clunky proofs that don't flow but are true are just mathematically valid, and that's fine. Probably at university, if you were my student and you were writing clunky proofs, then I would help you to write shorter proofs to save time. We would talk a bit about presentation. It says it in the question, James. What does it say in the question? Things a tangent? Oh, I don't know. Okay. Oh, it's given the centre is 1, 1. Oh, it's given the centre is 1, 1. Fine. No marks for finding out that the centre is at 1, 1. What are we given then? Oh, no. Okay, in my head, this is fine, this is practice. In my head, the question said the circle's tangent to both axes, and I've been acting as if it said that. Right, so how are you going to get those other marks then? I guess you're going to vaguely say something like, yeah, again, that's done some of the work for you. Brilliant, right at the top. Thanks, everyone. About 5 people have told me now. Thanks, chat. This is exactly what all the live streams are like. Okay, what are we doing? Gradient of PQR is minus tan theta. This is not hard. Do you remember that triangle picture I drew right at the start? The triangle with theta in here reveals that the change in y was something to do with the opposite side of this triangle, and the change in x is something to do with the adjacent side of this triangle. So it should not be surprising that the gradient, the ratio, change in y divided by change in x, is something to do with opposite over adjacent, which is tan theta. There's a minus sign. I'll leave you to work out where the minus sign is. Okay. Is that? Oh, we want to write down the equation for PQR. I would do this by focusing on the point. No, I would do this by focusing on. Oh, we know the gradient. So we know the gradient is minus tan theta, and we know it goes through. One plus cos theta, 1 plus sine, 1 plus sine, 1 plus cos. See, I'm so used to writing down cos, comma, sine. That's enough information to write down a line, I think, because it's why you could do y equals mx plus c and solve for m and c, or you could do my favourite, which is to write down y is gradient multiplied by x minus x1, and then add on the y1 value, because that lets you write it down in one line with no rearranging. Y equals. I might simplify this and multiply out, or I might not bother. Okay, the question wants to know where P is. P is at the point where y is 0. So you set y equal to 0 and rearrange this, and you get some unpleasant expression for x, I think. So P is at x equals, when is this 0? I guess I want 1 plus sine theta to remove this bracket, and then I also want, if this was 0 on the left, I'd rearrange by moving everything over and dividing by tan theta. So it's this. Okay, not very nice expression for the coordinates of P. Myra says I'm offline, so hey, maybe this isn't going anywhere. When did we prove the gradient is tan theta? Oh, very, very poorly. We talked out loud about how sine theta is something to do with this. Or even, let's do it one more time. And cos theta is OP divided by RP. The things that I want for the gradient are the change in y, which is minus OR, the change in y, and the change in x, which is OP. These are all lengths of lines. I'm being lazy and not writing my mod signs out, and they are all underneath chat, aren't they? So the ratio there is tan, which is not surprising. Tan is that ratio, so it gives you something to do with the gradient. Okay. What did I do? I did something very quick. Yeah, I really like writing down equations of lines and going through very quickly. So this tan theta thing really comes from triangles, and then over here we've got a line for PQR. We know the gradient is minus tan theta, and we know a point it goes through. I want to write down an equation of the form y equals mx plus c, and here's an expression that does all of those things. This thing here is, that is negative of this, and this bit over here is this, and that's the gradient out the front. I just know this formula for the equation of a line. I'd encourage you to learn a couple of different formulas for the equation of a line. And then I've rearranged awfully, but y equals 0 gives the coordinates of p, and I've tried to rearrange that, which I've done in one line. Nav says do -1 over perp. Oh yeah, that's much better. I like that a lot. Yep, Nav gets a point, not an actual point, just well done. The gradient of CQ from the centre to Q is, from around here somewhere, is, oh gosh, where is that, cos theta divided by sine theta? Because the coordinates are 1 plus sine theta, 1 plus cos theta. So the gradient of that line is 1 over tan theta. And gradients of perpendicular lines multiplied to -1. So the gradient of the tangent must be minus tan theta. That's much nicer. Wow, yeah. Point for a nice method. Why is it -1 minus sine? Okay. People seem to not really like my formula. Hopefully it's obvious this has got gradient m, and I claim that it goes through x1, y1, because when I plug in x1 for this value here, this bracket is 0 now, so I'm just going to get y equals y1. So that's why I put a minus sign in, because I want to subtract off x1, so that when I put in x1 it'll remove this bracket entirely. So that's what I've done up here. I want it to go through the point 1 plus sine theta, so I've put in -1 minus sine theta, so that if somebody comes and puts 1 plus sine theta in here, it will cancel the whole bracket, and they'll be left with whatever I write over here. And I'm going to sneakily write the y coordinate that I want them to get, which is 1 plus cos theta. So now I know for sure that if somebody plugs in 1 plus sine theta, they will definitely get 1 plus cos theta out the end. By design, you might say. Why is it? Yes, no, I just did that. Okay, good. Good, what are we doing? We've got an equation for a line, and I'm now going to accelerate because it's 6:30 somehow. How did that happen? I must have done something stupid, like talking about complex numbers or determinants of matrices. Sometimes happens. We're on part 2 of our first long question. Casual half an hour. No, it's fine. This is not too bad at all. There's a kind of symmetry thing to talk about a of theta and b of 90 minus theta. We're going to try and show that these are equal. And it comes back to that idea of looking at the triangle 2 ways that I mentioned in passing earlier on. Works like this. So this is a of theta. And this is 90 minus theta. But this is called b of theta. In the picture in the question, that's just called b of theta. It's not called b of 90 minus theta. That's annoying because b of 90 minus theta is the thing that I want. So I guess I should draw another triangle that actually has a b of 90 minus theta. How am I going to do that? Well, I suppose B always respects whatever angle you put down here. So I guess to satisfy that, I'll draw a picture with 90 minus theta. That circle is nowhere near to tangent. There we go. Okay, in that case, I guess this will be A of 90 minus theta. And up here, angles in a triangle, this will be theta because of the right angle down here. So now I've got a picture that's got A of theta in, which I like, and I've got a picture with B of 90 minus theta, and I need to try and convince people that these are the same. And they are the same because these triangles are congruent. These triangles are the same. They're like literally the same, just the other way around, right? They've got the same angles, the same size, everything's the same about them, which means that those areas that are marked on, they're the opposite way around. They've been, I guess, reflected, but not super important what the transformation really is. They're just the same triangle, pointy way up or pointy way across, which means that those areas are just the same. A of theta down here is the same thing as this area up here. So I'd write that one out a little bit. I think drawing the two pictures is the most direct way to have the idea about what's going on. It's the only way I can think of to really illustrate it. You definitely need something with a 90 minus theta in it, right? I imagine when people did this question, I wasn't around to be marking this question, but I imagine a lot of people said things like looking at the triangle the other way, or drew a picture like this where they labelled things 90 minus theta up here. I think this picture is a bit weird. Maybe you drew this as well, where you put in like theta, 90 minus theta up here, and you kind of say, aha, this is A of 90 minus theta or something. And this is sort of fine, right? You're sort of saying A is, oh gosh, maybe I'll say A over here. I don't know. And you're saying A is always the area. Oh, you couldn't see the picture I drew wrong because it was off the bottom. Maybe you draw a picture like this where you say, I've labelled this angle up here, and A is always the nearest area, B is the far away area, which kind of tracks, but it's a little bit clumsy. Right, okay. The angle related to B, right, is, what is the angle related to B? So you want to talk about how this thing up here, you've spotted this 90 minus theta up here. And maybe you want to try and convince me that the area near to 90 minus theta is just A of that angle, which is true. The way I would do it would be to reflect it over to make it look exactly like the specification in the question, where theta is that angle down there. The angle we're talking about is the one down by the x-axis. I'd flip it. Which also has the advantage of moving your A's and B's around so that you're talking about that area over there. Okay, the 45 degree case is then not too bad at all, because A of 45 is therefore B of 45. They're equal, because 45 plus 45 is 90. 45 is 90 minus 45. They're equal. If you draw the picture, everything is super symmetrical. Supersymmetry, brought to you by the Oxford MAT Livestream, and now the square feels relevant because now I've got a square, 3/4 of a circle, and two mystery areas that I've decided are equal by, just beautiful reflectional symmetry or something, or the facts that we just proved. So what I need to do is, I guess, find this side length, which we know that involves the coordinates of P. It's going to be a bit of work, but we're going to write down that length, square it, divide by 2 for the big triangle, and then I would subtract the square and 3/4 of a circle. I'm not going to do that on the screen because I'll probably get something wrong. And I'm running behind a tiny bit. Expressions for the area of the two sections to prove part 2 of this question. Oh yeah, you could, I suppose you could write down A of theta, write down B of theta, and show that. Brute force it, go for it. You could solve for how big A and B really are and show that those equations satisfy this relationship. That's fine. I'm not going to do it on the screen because it's quite a bit of work. Good suggestion though. Yeah, use the general formula of A of theta equals some horrible mess, says somebody in chat. And then, yeah, And if you found a general formula, then it's pretty easy to find a at 45, right? And also easy to find a of 60. So for a of 60, I don't have a nice symmetry like that. I would do something like this. Draw a new picture, for starters. 60 degrees, that is, I know not very plausible as pictures go, but I'm marking this 60 degrees, I think. So I've got this angle down here, so I kind of want to draw right-angled triangles that have that angle, or part of that angle. I really like these tangents being at right angles. It gives me right-angled triangles in places like this. So if I split it, then I get some right-angled triangles, which means I suppose these are congruent. They're both 1 over here, and they've got all the angles the same. So I think I'm almost there, right? These have got to be 30 degrees. This is 60 degrees, and now this is starting to look like area of a sector, 120 degrees, 1/3 of that circle. 1/3 of the circle is pi by 3. So I've already got the minus pi by 3. I just need to work out the area of these triangles, which again is going to involve the x coordinate of p to give me this length, and then I think I'm off to the races. Or even without that, even without working out that length from before, I know a side and an angle. So I think I know enough stuff. I know all the angles and one of the sides. This looks like half an equilateral triangle down here. Yeah, so 60 degrees is lovely. It's going to be fine. So there's some easy-ish calculations. I guess the key thing there was marking in this line down from the centre down to P. Not quite sure how I thought about that. I said something vague about right-angled triangles as I was doing it. I guess I really wanted to mark in that the kind of boundaries of A and mark in those radii. I was already thinking about triangles minus a circle because of the shape of the answer. Like number minus pi thing sounds like triangles minus circle to me. The area of a sector formula only works with radians. There's a different version for degrees, where it works like this. You say 120 degrees is 1/3 of 360 degrees, so 1/3 of pi r squared. R is 1, so it's 1/3 of pi. Hooray, good. Now, top secret fact, if you use radians, that's the same number as you wrote down for the size of the angle, but I don't know if you know radians. Degrees are our shared language, so stuff like this on the right might be what's going through your head. Lucia did this. I think it's good. Is the MAT time pressured? Yes, a bit. The MAT is 2.5 hours, and I think if we gave everybody twice as much time, people would do a bit more maths. But I think it would be a bit evil to make it too long. Okay, how am I doing? I've got 23 minutes to do a long question. Sounds fine. Ooh, how do we know that line bisects the angle? Seems obviously true. Miles, I would prove it like this. It's a good fact as well, so I'm going to do... Miles has asked for a proof that this is 30 degrees down here. Question kind of falls apart once you've got that angle in, because now you've got a right angle triangle where you know all the angles. How do I know that this bisects it? There's some really good congruent triangles going on. The radii over here are the same. These are right angles down to here. Is that enough? I feel like that's enough. Am I being dim? This line is shared between these two triangles. So they look really different in this picture over here, but actually, because the right angles, they've got all three sides the same. And they're right angles, so they're exactly congruent triangles, which means that this angle is half, because it matches the other one. Good. Two tangents meter to point equidistant. Radio calculating that. Obviously, bisect angle symmetry. Kind of, yeah. Basically, someone in chat's put kind of, why do you think it's kind of equal splits? I think it's congruent triangles. It usually is, right? There's usually some congruent triangles around if you're trying to prove that two things are equal in one of these. Pythagoras is back. Asked to find the number of solutions. Hey, those questions are good. We'll see some of those in a couple of weeks. We're going to go through past papers and we'll see some of those. How many solutions are there? I haven't done any of those, so I skipped all of them on the warm-up. There's some on the revision sheet, Pythagoras. Do you need to prove congruent? I would probably let you off, I think. For that bit there, I'd say, yeah, I mean, it is kind of obviously symmetric, right? We're quite generous I think we're quite generous with people saying, or people using things that are obviously symmetric, but maybe haven't proved that they're symmetric. This is again not great maths advice so much as exam advice. Examiners give you the benefit of the doubt sometimes. I don't know. Well, at least this one does. Maybe other examiners are more harsh than me. Right. Okay. Why is there a CS interview? Prove the basal problem. I don't know. That doesn't sound like a very good question to me, unless you get quite a lot of help. Because how would you possibly know how to do the basal problem? It's also not interesting if you know how to do the basal problem, because if you know how to do the basal problem, you just do it from memory, and if you don't, then I mean, yeah, terrible. Yeah, that sounds like I don't know who that is. I'll put it on the screen. Can we find out where? I would not use that as an interview question without loads more help. The basal problems, right? The sum of the reciprocals of the squares is pi squared over 6. Is that pi squared over 6 fact? Okay, right, good. Find out who's done that one. It's not Varun, is it? Okay. Today is trick. Why is there a circle question on the trick? Says somebody in chat. Aha. And somebody else has found a typo. It's impossible to do arc cos of -5 over square root of 7. I'll take that. So chat's picking holes in my question, or possibly my answer. Great news. I reckon you can, and I'm double checking on my calculator. I'm allowed to do that, aren't I? Oh no. What have I done wrong? Yeah, there might be a typo in this question. Probably I don't mean the square root. Yeah, I don't think I mean the square root. Yep, oops. Okay, this question is modified. You can tell because I put modified at the top. It's modified to give you two options down here, and one of them's got a typo in. Thanks, chat. It should be r cos -5 over 7, not -5 over square root of 7. Worse, I think the extension is to prove that these two parts are consistent. So I've managed to set myself an extension question. Yep, look, there's a -5 over 7 in my solution. That didn't make it back into the question. Okay, I can explain that when we get there. Always a typo, isn't there? Yeah, root 7 is less than 5. Okay. Criticisms as follows. Why are we doing this? Because it's got circles, no triangles. We're going to find a triangle and then use a triangle fact. I might even skip to that part of the question. Yeah, that sounds fun. And second criticism is, why have you got the square root of 7? Whoops. Okay. Good. Varun's done a basal problem. Right, okay, if it's Varun, then it's sensible. Bookmarking that for later. Yeah, no, hang on, it's not. It's about the basal problem, but it's doing loads of stuff. There are. I've clicked on the link, and there are 7 problems, seven parts of this problem, and it's by Christina. So it's a really well thought out question. Right. Okay. See, this is the little communication thing, right? Which I'm gonna. No, I don't have time. Sometimes people say, "Oh, my interview was terrible. It was just a basal problem," and then you find out that actually no, it was a structured 7-part question with lots of help and interviewers there to help you out to get through the 7 parts of it. Anyway, good. We're going to skip some of this question. I'm going to accelerate through the first 2 parts, which I think are kind of coordinate geometry, which is fine. We should all be able to do some coordinate geometry, but I want to get down to the cosine bit. Where, awfully, it's the cosine bit where I've made a typo. But we'll get there. Okay. I hope that's all right with you. Let's go. Right, so we've got a circle that's resting on a parabola. It shares a tangent at the point where it's resting, I guess, because a tangent to the circle would also be tangent to the parabola. They're both smooth curves, I guess. There's no sharp points, and if the tangents didn't match up, then one of them would be intersecting the other, and no, they're just neatly sitting one on top of the other. So what do I want to do? I want to find, they ask for this particular gradient, which, okay, fine. The gradient is not that tricky to find. It comes from knowing where all the points are. You see, I know that point B, perhaps I'm calling the coordinates of B x comma x squared, and I know the centre is at 0,2. These things are sort of in the question. So then the gradient is not hard to find. It's change in x divided by change in y, and it turns out to be x squared minus 2 over x. Next, it wants us to actually find the coordinates of B, and I'm accelerating through this because I fully back you to do this calculation at home to work out where these points are. As a clue, that this is a radius of a circle, and this is a tangent to a circle that's also tangent to the parabola. So we've got this kind of right angle. I've got two lines that are at right angles to each other. So long story short, it turns out that the thing you write down is this, which is two gradients multiplied together. This one's the gradient of a parabola, this one's the gradient of the radius of a circle. When do you ever have those at the same time? Circles, parabolas, they're totally different, right? Not today. You multiply them together and you get some expression which gives you the coordinates for B. So summary then of some maths that I'm not entirely doing on the screen. We've got the centre of the circle is at 0,2, and we found that B is at root 3 over 2, comma 3 over 2. And the maths to get there is not super exciting. Right, we're in speedrunner mode. The question then wants us to work out an expression. Now, I should admit, I modified the question. The first one was given in the question in radians, so I modified it to put it in degrees, and then I modified it again to give you another equivalent expression where I've made a typo. There should not be a square root on that 7, only on the other one. The reason I've modified it like that is that I've seen people try this question with kind of two different methods. It depends which triangle you draw. So the question wants us to find the area of the circle, and you sort of read circle and think, okay, fine, area of a circle, we need to find an angle, and we need to find out how much of a circle is this. So I need to find maybe this angle, alpha or something, which is not that bad. We know some points, we know the picture's nice and symmetrical. I'd be nice to you and not get you to explicitly write out that the picture's symmetrical, because parabolas are definitely symmetrical. So this point over here, A, is at minus root 3 over 2, comma 3 over 2. The triangle I would probably draw is this one. A up to 0,2 and then B over here. I know where all the corners are, so I know all the sides. I'm not going to use Heron's rule because I don't actually want the area of the triangle, and because Heron's not on the math syllabus. I'd be allowed to use it, but I don't want to. I want an expression of this angle, so I think it makes sense to talk about the side lengths. So I'd write down all my side lengths, write down the cosine rule, and then get that angle. That's my plan of attack. Equally valid is to draw this triangle with 0,2 at the top, B over here, and to say, aha, I just want to find out this angle. I'm going to remember to double this at the end, because this will give me an angle to give me part of the circle. I'll need the other side as well to get out to A, but I'll find this one, and it's actually slightly easier to find this angle, because if you just want, you can just write it inverse cos from your right angle triangle trigonometry knowledge. Maybe you know this distance is 1/2 because of the change in the y coordinates, and then you've got to do some Pythagoras to work out how long the hypotenuse is, the distance between those 2 points. And then you could write down arc cos of that. Spoilers, that turns out to be that method, which is probably the better method, involves 1 over root 7, and the method I was using with big wide triangle gives you this minus 5 over 7 inside your arc cos, inside your inverse cos, which I've then, in anger that my expression was not the one in the question but is correct, I've put in my answer. I've written my answer into the question. That's the power if you're in charge of the worksheet. You can write your answer into the question. Nobody stops you, even if it's got a typo in it. Okay. So two different methods of attack. I hope it's clear which triangle I mean for this one. It's like you have the choice of splitting the picture in two, to use the fact that the picture is nice and symmetric and to look at the left and right separately. I'm going to quickly point at the diagram up here. Look how symmetric the picture is, left, right symmetric, right? Left. You could have the triangle from A up to the centre to B, or you could chop it at the y-axis and just look at the right-hand side of the picture. You can find the area for that sector down there. Okay. And Miles asks in chat, if we see an or equivalently, this means we can give either answer and not show that we mean this answer, show this answer is equivalent to the other. That's what I meant. If I'm honest, no past question has ever said show this or equivalently this, because it seems confusing, right? So sorry if you read my question and thought that it meant show the correct thing and also show incorrect thing and show that correct thing and incorrect thing are equivalent, then sorry that I made you do 3 times as much work and some of it nonsense. Yeah, right. If you see an options for what you're supposed to prove, I would prove one of them. Question in chat: what happens if there's a typo on the actual mat? If there's a typo on the mat, we take it into account during the marking. This happened in 2020. There was a typo in the mat, which meant we defined something in a weird way. About half the people then did the question using that weird definition instead of the one we meant, and we gave everybody marks for doing stuff with the definition. We did our best to award lots of marks to people who were confused by the weird definition. So in this case, if I made a weird mistake like this, with the square root on the screen, people would probably end up getting marks for writing a lot of things with square roots in. It's not ideal, and it happens very rarely. Don't be stressed. Yeah, Nav remembers. Oh, is it possible to do this question using the fact that the gradient of the line is minus tan theta? Hey, yeah, I like that. I like that. Let's go for that. So the gradient of the line, right? Hey, you remembered a fact from the other question. I love it. So if you mark in this theta over here, for, I guess this is this angle in here, minus tan theta is then call back to the other question, x squared minus 2 over x, call back to this question. It all links together. Wow. And then you've got some really cool expression that involves inverse tan. So maybe I should put a third equivalent thing in that's like another expression involving inverse tan of something else multiplied by the area of the circle. I think I won't, but yeah, there's other expressions that you might find. When you draw the picture, it's not obvious that you would pick inverse cos rather than inverse sine. I mean, there's another expression where you look at the triangle, you can see all 3 sides, and you write down your favourite trigonometric expression to work out what the other one is. Yeah, so good suggestion, anonymous person. I like that. Thinking about other ways to do the question makes me happier than thinking about typos does. The mat is checked by a panel of people who go through and look for, especially looking for mistakes in the question or looking for how difficult the questions are. Questions are checked by a lot of people. Put things in place after the typo happened in 2020 to make us even more careful than we always were. Right, okay. We've got a couple of parts left for this question. It goes back to being the kind of algebra thing from the first part that I did very quickly. I want to talk about it very briefly, I think. This is a part at the end of the question that tries to adapt the working to say maybe now the centre of the circle isn't 0, 2 anymore, it's at 0, a. There are 2 ways you can react to that. One is to throw away everything because none of it's true anymore. The centre isn't at 0, 2, it's at 0, a. Throw it all away and try drawing some new pictures. But there's this other slightly more mature response where you look back at your working and you try to see what that would change. Okay, maybe it would change everything, but maybe it would maybe it changes everything, but maybe you can see where it's going to change things, and maybe you decide that you're going to lay out your work in the same way as you did last time. That can be really helpful to work out how does this change affect things. What sort of things did we do last time? Can I do those sort of things again? If your reaction after you've read this question and thought about it is to write down the gradient for the line from the centre to the point where B would be, then you've got very good instincts for adapting questions. So yeah, well done if you wanted to write down a gradient for this part. I don't even really mind so much as if you wrote down something like this for a gradient, then I think you're making life easier for yourself because you're following the steps that you already did. You're almost retracing the path, but with A instead of 2. Of course, there are other approaches to do this. This is sort of free form at this point. You're not being told how to do the question, but you can make things easier for yourself, I think, if you try and learn from what just happened in the question. The reason I'm telling you about the question rather than doing the question is that there's a transferable skill here, that the ends of questions sometimes test understanding of the previous things, and they're looking for you to do something very similar, but with different numbers, or with a different idea along the way, or a different twist, like the quadratic now has 2 roots instead of 1, or now the cubic has turning points rather than no turning points. There is nothing special about 2. I don't understand what the question is asking. Cool, so if you have a parabola, we've seen a case where the circle is touching the parabola at 2 points like that. Oh no, I've drawn a terrible parabola. My parabola is the same shape as my circle. That's a disaster. Let's do another one. Okay, not very symmetric, but good enough for today. It might be tangent at 2 points, here and here, but if it's a really small circle, then it will roll down to the bottom of the parabola and it'll just sit down there. You can probably imagine both, right? You can imagine a large circle that's wedged in the parabola, like in the original diagram, up here. And maybe you can also imagine a small circle that falls down to the bottom. It makes it all the way down to the bottom. That's maybe not obvious that happens, but you can do the algebra. If you try and solve for the point B, by solving some algebra that looks, I suppose, like this, what do I want? I want the gradient multiplied by the gradient at B to be minus 1. Most of that's the same. What you get when you multiply up is something like 2a, and there's a x squared. No, I've got lost. I'm going to cheat by looking at my working out down here. Yep, that rearranges to 2x squared is a minus 1. So if a is large, then you get some roots for where to put a and b, but if a is too small, then you don't. What on earth have I written? That's just complete nonsense, isn't it? I've been divided by 2. Always a typo. What am I doing? Slight pause here while I work out what on earth I'm doing. Oh, it's 2a. Good. Yeah. A is positive in the question. Good. That was a complete failure of multiplication. Good times. Let's switch chat on. Let's see if chat's got anything to do. Yeah, I didn't divide by 2 successfully. No, well done, James, in chat for that one. Okay. In the different cases, you're asked to find the radius of the circle in the case when it's jammed inside the parabola. That's what we did before. We worked out that length, or I think I said that it would be easy to find that length with Pythagoras. It's still easy to find the length with in this case. I really like the comment in chat thinking about there's nothing special about the number 2. which is a good way to think about it. And that's a really honest thing down in chat. Someone said, I was just imagining the circle getting bigger. Thanks for putting that in chat. It's a good thing to say. What was in your mind? It's good to be able to analyze what you were thinking. I find it quite hard to remember what I was thinking. Welcome to the MAT Livestream. 1 times 2 is 2. Good. Okay. Yeah, discriminant for quadratic, right? Or you could just talk about how the people in chat are talking about discriminants, and I couldn't really tell why, but I realised they can see a quadratic on the screen, and they want to talk about how many solutions it's got. I think I would just talk about how this thing is a square, so it's positive. So we want the right-hand side to also be positive in order to get solutions. I guess I'm sort of solving it, sort of, in some sense. Not a very accurate sense. Good. Okay. I think I've hit, in some sense, the end of the question, despite skipping a lot of things along the way. I really wanted to focus on the trigonometry, and I annoyed myself by putting a typo in. Sometimes there's more than one method in the question. Maybe the questions could list more alternative answers sometimes, or alternative formats for the answer. Sometimes when the question is a bit open-ended, there are lots of things that you could write down that work. So thinking about that. There's so much that's special about the number 2. Okay, yeah, I know I said it just now. In this context, there's nothing special about number 2. 2 is the only even prime. That's a very good fact. Good, okay. No, we've got 3 more streams before papers in a month's time. We started early this year. So normally we'd only get onto past papers in about September, October, but this year, August, hooray. We've got 1 more of these on sequences and series, the, as foreshadowed, ideas about summing together infinitely many things, all the way back up here, next week. There they are again. 1 more episode on those, and then 2 episodes on question 6 on the MAT, question 5 and 6 on the MAT for computer scientists. But actually question 5 is for everybody. Everybody does question 5, so I'm hoping that's useful for everyone. There's no revision for that one, it's just problem solving skills. And then after that, 3 episodes between us and past papers where we're going to look at everything from 2007. Yeah, tangents. Right, good. The plan is maybe to go through a couple of questions. Am I celebrating Hatfest? Oh, Burn's in the building. You're in the building, Burn. The call was coming from here. The live stream viewers are inside the building. There's something called Hatfest going on at the moment. I might drop around. I might drop in. We'll see. Does anyone consider 1 as prime? Right, good. Okay. I think I'm going to wrap up there. I don't know if anyone wants to do any quick Q&A chat. If I missed your question earlier, I'm going to give you a chance to ask it again now, and then I'll either answer it live or I'll try and type something in Slido. If you're watching the replay, you're welcome to put a comment in the YouTube comments. We try to check them about once a week, so sorry if we're very slow on that. We're not used to checking YouTube comments, we don't get very many. People want me to react to a YouTube video. Am I going to do that on here? Can I do it as a bonus stream? Can we do it in the not maths one, right? Can I do it in a bit? In a bit. Oh, I'm going to try and find it. Oh, has Tom already done a video on this? Everyone's done a reaction video. I've just googled it and there are so many. Is it someone who doesn't like maths? Let's find out. Oh, it's 15 minutes long. I'm not doing a 15-minute reaction video. Nobody wants that. Right, cool. I was about to do it, but it's 15 minutes long. Bonus episode time. And someone in chat shouts flashcards, which is a reminder for me to do my actual job instead of watching YouTube. Reminder for all of us there. People like it. Is it good? I shouldn't get, okay, no spoilers. At some point, bonus stream or something. Tom's already done a reaction video though. Don't want a 15-minute bonus stream. I'm not going anywhere. Almost, but not quite. Why do we call it the Maths Institute? Why do you call it? We've always been the Maths Institute. We're technically not a department. That's a very, very confusing answer. Right, cool. We almost got it, but I'm saving it for another time. Not a James reaction video. Yep, good. Right, cool. I now feel that I've done a bait and switch on chat, which is very rude of me. Real question, right, hang on, real question, let's do that. For questions where you must explain your answer, must you prove everything you state even if you get the answer? I would say no, which is a bit of a hot take, maybe that's controversial. You need to write enough that it's clear you're not just bluffing or guessing, which you're probably not, right? You're conscientious, you're thinking about math questions, you're keen on maths, let's say. Sometimes people don't want to write anything, and I need to encourage people to write at least something, not nothing. It's this challenge, right, that if the question says, why prove that cosine is something else. Right, more than James puts on the work solutions. Oh yeah, okay, so the work solutions on the web are a bit short. I'm trying to make the ones on the MAT Livestream resources a bit longer to be a bit more realistic. Trying to get better at writing out solutions that are a bit more realistic. Yeah, so it's less convincing. You state things without proof. Yeah, David, you can if you want to. If you think it makes the question trivially easy, then I'd encourage you to write something else, maybe as well. So if you think, this is easy, it's just the ABC conjecture, then I'd encourage you to maybe write down something else as well, because ABC conjectures may be proved, maybe not been proved. Yeah, okay. How you must convince the examiner to be convinced you know the answer. Yeah, so I'd say the stages are, first you should know the answer, and then second you should write something which shows that you know the answer. Let's not overthink it, I reckon. The main thing is you're going to do the maths question and write down something along the way so that it's clear that you've done the maths question. We're not mind readers. If you don't write anything, we won't know what you were thinking, but we're not trying to catch you out. We're not trying to pick holes in, gosh, you forgot to dot the I and cross the T. Right, what are we doing? Workings for multiple choice questions are not marked, but they do get scanned, and the tutors at Oxford can see you're working out, which might be nice if they want to see how you're thinking about a question. There are some general themes in the past questions. I don't really agree with all of Nav's suggestions. I would say generally 3 and 4 have been more. Sometimes 3 is more integration-y calculus kind of themed. 4 is sometimes geometry, trigonometry. I'm not sure I'd describe 5 and 6 as logic. I think they're less themed. This is not a promise for the future. This is just, I've had to look at lots of past questions, and that's kind of a sort of 2 and 5 have to be quite generalist because they're for everybody. 3 and 4 can be a bit more on the side of inappropriate for computer scientists, I suppose. Although now computer scientists do 3, so I guess changing what computer scientists think is appropriate. 6 can be a bit more in the computer science direction. You can kind of work out what the theming is by who's doing the questions. How does PSI work? Hey, you've heard about PSI. It's not a simple percentage. It's a complicated linear regression. We did some statistics. So, side note for other people. Jay's heard about the PSI formula, which Oxford Maths uses. We did some stats looking at MAT scores and one measure of GCSE performance, where we've got GCSE performance. And the stats came back with pretty much exactly what we were expecting, which says that MAT is really good for predicting interview scores, but the GCSEs aren't nothing. Maths much better than GCSEs, but you can do a kind of linear combination in this way that works as a predictor. We had to do the stats because we like that sort of thing. It's not the only thing. Yeah, we got the stats department involved. We like the stats department. Is it possible to get error carried forwards? Yes. Is it affected contextually? Oh gosh, I think the GCSE metric we now use. Sorry, back to Jay's question. I realised there were like 3 or 4 questions in there. The GCSE metric that we use has some contextualisation on it to look at school cohort GCSE results. That's a very complicated and technical answer to say that that element is a sort of contextualised score. That's a very small bit of contextualisation on a very small part of one score, which is a very small part of the application process. But I guess short answer, yes. Are there stats in the MAT? Nope. You can tell because there's no stats in the MAT syllabus, which we're going through. We're getting through the MAT syllabus quite slowly. If you would like to see the whole thing, it's one side of A4 paper. It's 1 page. You can get it on the MAT website. Good, just Pierre. Do I care about non-math GCSE results? A tiny bit. Our stats came back and said that people with really good GCSE results seem to be doing well in exams and other stuff in general. So our stats thing looks at GCSE results in general, but that's just one measure of how well did you do in a set of exams a year or so before you're applying. MAT score did much better as a predictor. Is there an Oxford? Yeah, okay. Now I've given the impression that there's an Oxford admissions equation, and really I just need to give you the impression that there is a single bit of statistics which we use for a guideline. We don't let the statistics actually make the decision for us. But at some point, if you've got all this data and you want to try and predict things, you might try and do some simple stats, which is what we did on just one pair of numbers, I suppose. MAT scores and GCSE performance score. We don't have a full equation that does, I don't know, it would have to be something really horrible that looked at your personal statement and all of your MAT working out and everything, and no, I don't have an equation on weightings. Okay, can we reverse engineer the equation? I think it's out there. It's not very interesting. It tells you that basically we think that MAT score helps us predict how the interviews are going to go, more or less, and then we do the interviews anyway. So by the end, we don't need the predictor score because we've interviewed people. It's trying to predict interview scores for people we then ultimately interview. So by the end, doesn't matter that much. How important is personal statement? Not as important as MAT, definitely. And your A levels. Well, let's say you're doing maths and further maths and you're getting A star in both of those. Beyond that, you're getting, I suppose, A in a third subject. Seems fine. It would be very unusual to be deselected because of your personal statement. I don't really know how you'd do that. It's very easy to get deselected because of your MAT score. I don't know how you'd get I think you'd have to write a personal statement where you said something like, I don't actually want to do maths at university. I don't know. Not everyone is interviewed. Fine. Okay. So the predictor works by looking at interview scores of people we interviewed, and that is a biased sample. Yes. We don't let the statistics make the decisions. How much maths are we allowed to assume? You can assume stuff in the syllabus. You can quote it back to us from the syllabus. You probably don't need to assume very much more. We don't want to write questions where you have to write down the shoelace theorem or the PICS method of things. Yeah, and Jay's also spotted that, okay, some people have high MAT scores but were not interviewed. And this is a result of the fact that it's not just MAT scores we look at the rest of the application. I can't comment on individual cases. We will look at the rest of the facts available to us. Access arrangements for A-levels, you should probably also get something for MAT, yes. So for example, if you get extra time or if you get larger writing, or you should talk to your test centre, which is probably your school or college. Make sure they're registering at the moment to get you to take the MAT and make sure they're aware. They're probably already aware if they're doing A level. Good. What do these terms mean? Says someone in chat, and I missed because of chat lag. I can't remember what I was talking about. I can't remember which weird terms I've used recently. GCSE? No, not that. Can you ask that again, but with the terms that you'd like me to explain? I use a lot of jargon and a lot of made up words. Bye, David. Syllabus? The syllabus is a page of topics. Well, okay. If somebody was already in first year undergrad maths and applied to join as a second year and got 80 on the math, is less impressive than someone who got 80 fresh into year 13. Yeah, Nav's got a good point. That if you're at university already and you're studying a lot of advanced mathematics and problem solving skills, then yeah, probably I would expect you to do quite a bit better on that. AFC homework from last time. Accurate to describe the curve between -1 and 1 as sigmoid. Burn. I think a sigmoid is a particular function. I know that. I think that some people use sigmoid as a general kind of adjective for something that is sigmoidal, perhaps, as maybe the adjective. Let me try and do an English language check. So sigmoidal means S-shaped. So I think I'll let you get away with calling it sigmoidal. If you want to call it a sigmoid curve, then I get very nervous, because I think a sigmoid function is a very particular function, which this one's not, which happens to be S-shaped. I know that's a really weird, niche kind of concern, that lots of things are S-shaped. One of them is so nice and so S-shaped that it's called the S-shaped function, more or less, with sigmoid instead of S-shaped. Are there questions from interview based on the maths syllabus? Yes, but also with that example that Varun and Christina have, I'm going to put it on screen, I think. So on screen is a question by some people at LMH. This function is about, the zeta function. You don't need to know it's the zeta function. You don't need to know anything about the zeta function. They're going to ask you about the lower bound and stuff. So is this based on the math syllabus? Not really, but Varun's there and Christina's there to explain things to you as we're going through. Oh, in fact, this thing is true. Aha! They tell you halfway through that pi squared over 6. One proof of this relies on this. Can you show why this is true geometrically? Aha! And look, this is in radians. So, I think it's not entirely accurate to say that, oh my goodness, this question is amazing. Oh, I like this a lot. Oh, if you get through to the end, you end up proving the thing. What a weird polynomial. This is great. This question is due to Christina. It's on the website. Hey, Christina. Cool, right. So I think it's not quite true to say that's based on the math syllabus, because they can go wherever they want with that question, right? They can make it different. Don't see an S. Sigmoid curve, right? Sigmoid curve? Looks like an S. Is this not S-shaped enough for you? It's a bit S-shaped. Sigmoid function. I guess it could look more like an S, maybe. Yeah, it really could, couldn't it? Other interview questions? Varun's got a few on the website, and we're going to do a bonus live stream at some point in November, I think. Check the schedule on the Mat Live page. I'm talking about interview problems on here at some point. Interviews are only 20 minutes, so yeah. I didn't put that up before. Okay. Other past papers? Gannon, you might also like TMUA, you might like STEP, you might like AEA, you might like, in the UK, things like BMO or IMOK, or if you're getting really advanced, you might like the IMO. There are loads of these acronyms. It's really hard to keep them all straight in my head, but there's loads of these acronyms of other places to find maths. The pink kangaroo is fun too. That one's not an acronym. That's just an animal. Nav wants to know what my favourite college is. My favourite college is currently New College because I'm currently teaching at New College. Can change year on year. Interviews spoken to you, shown paper. Might do either. This year interviews are online again, so we might write something on the screen. Probably a bit of both. I like to talk while writing because that's what I've learned to do on these. Yeah, okay. Which question papers have got lots of series questions in? STEP has got quite a lot of series questions in. Let's find some now. So STEP comes with a database, which I'm a bit jealous of. The STEP database, I've just searched for STEP database.maths. And if I go in there, it's got a list of all these questions, so I can maybe try and find you a series question. Ah, yeah, here's some. Ah, good, yeah, okay. Thank you, Alicia. Oh, it's on the wrong side of the screen for you. Let me just put it over here. That hasn't worked at all. That's a total disaster. Yeah, okay. So we want a geometric series maybe. Let's put geometric in here. There you go. Oh, it's interest. STEP has got some probability in it as well. This looks fun. 2, 4, 5, 7, 8, 10. What's going on here? 3n minus 1. Ooh, looks very complicated. Do I need to buy a tablet to do my interview, says Nav in chat? No. We can work it out. Am I going to be at New College in 2024, James? No comment. I don't know. Is combinatorics part of the syllabus? Can be used for math? Yes. Binomial probabilities and combinations and permutations are part of the algebra section. We had an episode a few weeks ago about algebra. Receive an offer but don't get the grades. I can't recommend other particular universities. I don't think that's fair. Sorry, I can't tell you which university to put as insurance. Well remembered, Nav, at the top there. There's actually a train strike today, so no trains. Yeah, that sort of thing. Receive an offer but don't get the grades, and then get the grades after resitting. So the way this normally works is that the resits don't happen soon enough. The rules for making your UCAS offer are that you have to make it by a particular date, and there's a time limit, which is before the start of the university course, which means that in practice if you don't make the grades there isn't enough time. There's like a couple of weeks, there's not enough time to resit the exams. So unfortunately this doesn't really happen. You don't, I'm afraid, automatically get anything like an offer for next year or a different sort of application process. You could apply. I would say you wouldn't have to. Like presumably you've got some sort of insurance offer, which hopefully you've made, and at that point you still get your insurance offer. Good. Okay. Yeah, Miles has got a point in chat there. I've also lost Yuhan. Sorry, Yuhan. Because I told Yuhan I'd stop at 7. Right, good. Any advice to understand the topics better? You're going to have to think about them. You're going to have to try hard problems that you can't do straight away. And you're going to have to throw yourself into these situations where you don't quite know what's going on. I know that's scary. I know that's not really what you want as a default. But it's the only way to get better at doing hard problems. Not good at... Oh, no, sorry. I am good at maths at school. Sorry, I totally misread that thing at the top. I read I'm not good at maths. I thought, wow, you've sat through 2.5 hours of absolutely terror then. Doing good at maths. I've got maths questions. Not Olympiads, maths challenges. Oh, no, that's fine. Yeah, that's fine. Olympiads and maths challenges have got a lot of other stuff going on. You can learn that kind of skill at university. I learnt it by... hanging around with a teacher who could do that sort of question, and then at university I would have picked it up anyway by hanging around with that sort of people. No, Nav, I've got to go. Nav, I've got to go and get a bus, which I think I'm going to go and do now. Is there a way for solving x when it's both the base and the exponent? 3 to the x equals x squared. But the bus. The bus. Oh no, these are really hard. These are really hard. Oh no, hang on. Yeah, hang on, you can do something clever, right? Maybe not. Maybe not. No, I can't think of anything clever to do to solve your equation. Good question. That's gone. Do I care about extracurriculars? If they're not related to maths, then they're not part of my admissions process. Sorry, I know that I've now sped up to the point where I'm answering questions before they appear on screen. Olympiad questions I would count as supercurricular. I distinguish extracurricular, stuff that's not maths, supercurricular, stuff that's super, extra sorts of maths. It's not a good distinction. If you're doing extra bits of maths, then I think that's probably good for you, whatever they are. And I mean that whether they're Olympiad maths or not Olympiad maths, it doesn't matter. Just doing maths problems that you can't do straight away. Is chess related to maths? Good question. I don't know. Up to you. It's your personal statement. You're going to write something convincing either way. I've got to go. Right, okay. What forms of supercurricular? This counts. Supercurriculars computer science. Check the computer science website. You are probably able to build things with some sort of get a computer to solve some problems for you. The Project Euler website is absolutely brilliant. Obviously, do you know about the Project Euler website? The Project Euler website is so good. There's a picture of Euler. You go to the archives. It's got these maths problems that you have to get your computer to help with. Like, what's the 10,001st prime number? That question is just awful if you don't have a computer, but if you have a computer to help, off you go. Yeah, now if I would do something iterative. Right, cool. There's buses all the time, it's fine. Thanks for your concern. I am going to go. That was quite a fun half an hour. Maybe I shouldn't have rushed the question. I could have spent more of this time doing the question than watching YouTube videos with everyone. Right, cool. Bye. Take care, everyone. See you next week for Sequences in Series in 165.5 hours. Bye.